Today we're going to be learning about box plots. So box plots, well, they used to be called box and whiskers, and if you're ever searching on the internet, you might see something for box and whiskers, and it's the same thing. They dropped the whiskers part and just called it box plot, but they are the same thing. You know how stuff gets changed. But a box plot is a diagram that is constructed using the median, quartiles, and extreme values. So a box is drawn around the quartile values, and the whiskers extend from each quartile to the extreme values. So this will make a whole lot more sense once we label the next part. The number of games won in the American Football Conference in a recent year is displayed below. Determine the median and the measures of spread, then interpret the data. Well, if you remember when we did that little hand, the physical middle of our hand is the median, that middle finger, right? So let's label that. So it divides my information into the lower 50% and the upper 50%. So this is 50% of my data, as well as this is 50% of my data. So this is called the lower extreme, and this is called the upper extreme. The median of the lower part, that lower 50%, the middle of it, the median, is called the quartile 1 or the Q1. And this one is called the Q3. It is the median of the upper 50%. So the first thing it asks me to do is to decide what is the median. And so I really just have to know how to read my chart. So the median is the middle, and it's halfway between the 8 and the 9, so my median is 8 1/2. So when we found that one, but we need to look at the measures of spread. There's a whole bunch we have to do with that one. We need to do the IQR, we need to do the range, and go from there. So I'm going to start with the range because that one's a pretty simple one for me to do. I take my highest value and my lowest value and subtract. So 13 minus 1 is 12. So let's look at my Q1 and my Q3. I need those values so that I can get my IQR, the interquartile range. So Q1, I come and read it, and it's the end part of my box, and that's 5.5. I go to my Q3 and I read it, and that's right at 11. To get my IQR, I need to find the difference between those two. So I'm going to come over here and do 11 minus 5.5, and when I do that, I do get 5.5. So my interquartile range is 5.5. In this case, there's no outlier. If I had an outlier, it would be a point out this way. So we're going to go ahead and just mark that and put outlier. And this one has no outlier. All right, so how do we interpret this? Well, if you look at this upper 50%, it is more concentrated than this lower 50%. So that's one of the observations we can make. So I've typed out that the upper half is more concentrated than the lower half, which is more spread out. So we don't know exactly what the scores are. We don't know where they do, but we do know ranges on this. We know, whoops, didn't mean to do that. We know that the lower 50% is larger. The upper 50% is more concentrated, but we don't know exactly where the numbers go. We know our lowest is 1, our highest is 13, our middle is 8.5. So we get to make some general assumptions with this. So here's a star problem. Students recorded the amount of liquid and fluid ounces each of them drank in one day. The box plot shows the summary of the results. So let's go ahead and label our pieces just so that we could be a little bit more familiar with where the pieces go. The middle is my median. This is my lower. This is my upper. This is my Q1, where that line is, the end of the box, and Q3, the other end of the box. So, wow, that upper doesn't look good. So let's look at our choices. It says, which statement best describes the data presented in the box plot? Half of the students drank from 78 to 114 ounces, fluid ounces. The greatest number of students drank from 30 to 78 ounces. The data represents 78 student responses. The mean number, the average number of fluid ounces that the student drank is 78. One of the first things I need to do is look at the increments of my table, of my number line here. And I see I go from 12 to 24 to 36 to 48, 60, etc. So my increments are counted by, it's plus 12 every time. So half of 12 is 6. So I kind of need to keep that in mind. So I'm looking at this first one. It says half of the students drank from 78 to 114. So 78 would be right here, and 114 would be right there. And it says half of the students. Well, that one seems plausible because that is 50% because it's the upper half. So I kind of like that one. We'll see. All right, the second one says the greatest number of students drank between 30, which is right here, to 78. Well, even though I don't know how many students did that, I do know that that is my lower 50%. So the greatest number, no, because that's 50% and the upper part is 50%. So if it's 50%, it cannot be larger than the other half. So that one's not going to work. The data represents 78 student responses. Well, I don't know how many students they asked. I just know that this is the information they recorded. The mean, remember, mean is the average number of fluid ounces the student drank is 78. Well, I don't know because I don't know each specific one. If you remember, the median is the physical center of the group. The mean is the digital center, when I actually do the average. So since I don't have specific points, I can't answer that one with the mean. So that one is not true. So we're going to stick with our first choice, F.